Now we'll come to the second part of the lecture, which is how to produce the X-ray beam. First of all, the main component of the modern X-ray beam, it will be like an anode. This is the anode. And this is the anode, or sorry, the cathode, which is this one, the cathode, which is the source of electrons. The electrons will be travel from this side to this side. So the source of the electrons coming from the cathode, space here, evacuated space between the anode and the cathode. This space should be vacuum. There is no air, nothing there. There is no material to speed up the electrons. High positive potential to accelerate the here is like a high positive potential to accelerate that one, to accelerate the electrons. And we have a target or anode, which is electron will be struck on it and to produce X-ray. The procedure is this cathode will be they will give it like a what we said, just like we will raise the temperature for that one, so we will make it heat up. The electrons will be excited, and then the focusing up, or the film, the focusing up here, this one. So to make the temperature is high here, the electrons will be run away from the cathode, going to that way. And after that, the electrons will be go to the anode and hit the anode and make the X-ray beam. We will see it on that one. High-speed electron can convert some or all the energy into X-ray photons when it strikes on an atom. And thus, we need to speed up the electron to produce X-ray. So if you want to produce X-ray again here, if you want to produce X-ray, the electron should be speeded up. After that, just like how can we make the electrons will be speed up? How can we release the electrons? Electron tube that will produce electron by pulling them off of red hot of filament. So here you will pulling it up, so you will make the high temperature here. You will release electron from that tube. The intensity of X-ray being produced is highly dependent on the anode material, which is referred to the high atomic number and high melting point. Just like the intensity of the electrons beam will be highly dependent on the anode material. So to produce high X-ray, this one will be high. It will depend on the anode. What is the properties of anode? Should be high atomic number and should be high melting point. For example, tungsten is more preferred. Why? Because the atomic number of the tungsten is 74. So number of protons is 74. Melting point, number of just like the temperature that it will be make the tungsten, it will be melted, is 3,400 CDC. So these 2 points is important to make to choose the anode material. How can we accelerate the electrons? We will accelerate electrons by depend on the temperature of the filament. If you have a high temperature, you will have high number of electrons will be accelerated. Okay. The kilovolt peak using for the X-ray study depend on the thickness of the patient, type of the study being done. And this one is not really important in your case here. The advantage is, though, sometimes you are using the X-ray here as a rotating anode. The anode will be rotating. Why it's rotating? Because it's just like the advantage of rotating anode is to avoid overheating of the anode. Because of the overheating, produce a damage of the anode. So we are using the high pulsing tungsten, and furthermore, we are using a rotating anode. This rotating anode will be help us to make the anode will be not avoid the anode to be overheating. In terms of the interaction, when the proton is coming and then coming to hit the electrons coming and hit the protons, it will be two types of X-ray will be produced. We name it characteristic X-ray and Bremsstrahlung X-ray. These two types. Which one is more important one in our case for the X-ray machine or X-ray imaging is the characteristic X-ray. It starts with the characteristic X-ray. A fast electron strike a K electron in the target atom and knock it out orbit and free of the atom. The vacancy of the K shell will be almost immediately when the electron from the outer shell of the atom fall onto it. And in the process, a characteristic X-ray is produced. So the idea is just like one of the X-ray will be coming and hit the K shell electrons. Okay, or high electrons will become and hit the H shell. This one it will be release electron outside. So it will be make this electron, it will be released, it will go outside. Okay, one of the electrons from the outer shell will become and fill this hole. It's happened on that K shell. Maybe it's coming from the third one, from the M1. We name it K beta line, which is the characteristic X-ray. Sometimes it's coming from alpha, so it will be K alpha line. Okay, and this one, when it's come, it will be release X-ray. Okay, it will be release what? It will be release X-ray. This X-ray will be used for the imaging one. The emitted photon is named according to the shell that we struck. For example, we have K shell, L shell, characteristic X-ray, and so on. An X-ray can be a photon emitted when an electron will be fall. How can we X-ray be emitted? When an electron fall from the L level to the K level. It's called K alpha characteristic X-ray. When an electron falls from M level to the K level, it will be K beta characteristic X-ray. The energy of the emitted photon depends on the energy difference between the shell that have the vacancy and the outer shell, which is the electron coming from it. So the difference between the shells give you the energy of the photon that will be emitted. The second one, the Bremsstrahlung X-ray. This type of X-ray produced by the sudden deaccelerating of high energy electron. When the electron gets close enough to the nucleus of the target atom, it will be diverted from its path. Okay, when the electron is coming from outside, it will have high energy and it will go to hit where? To hit the electrons, to hit the nucleus inside. That one will be enough to the nucleus of the atom and will be diverted from its path. It will be like changing the direction of its path. This type sometimes called white radiation because it's analog to the white light and has a range of wavelength. It depends on the Z of the target, how many protons you have in the target. The more protons in the nucleus, the greater acceleration of the electron. The kilovolt peak, which is not required from you, so skip the P, is depend on only the Z of the target. The more protons in the nucleus, the greatest acceleration of the electrons. How X-ray are observed? X-ray are not observed equally well by all the materials. This is the idea for the X-ray. Heavy elements such as calcium are much better observed of X-ray than the light elements such as the carbon. To understand these properties, we will review how can the observation of X-ray will be happen in terms of our tissue. And this is the end of part 2 of the lecture. Thank you very much.